Thank you very much indeed. I'm going to talk about a lesson of caution from experimental studies of hypercapnia. I have no financial conflicts of interest with this. I have research support from an endowed chair and from federal grants in the Canadian system. I've been very fortunate working in Canada to have had some very gifted trainees and fellows work in our lab. One of the most gifted is John Laffey, who's now an established independent investigator. I'm going to describe a solitary lesson from 2 studies of hypercapnia from John's group. Hypercapnia and pneumonia is a double-edged sword. I'll use 4 data slides to make my point. This is a study by Mairead Ní published in Anesthesiology. It's a E. coli model, short-term model, 6 hours, of pneumonia in a rat. This is a graph figure of morphometry. The y-axis is the increasing percentage of either airspace or tissue. A worsening pneumonia in such morphometry has less airspace and more tissue, more consolidation. These animals exposed to either air or added CO2 show the following result. With hypercapnia, there was more air and there was less tissue. That is to say, the pneumonia was less severe. Well, 1 point for hypercapnia. In the short term, if you're a rat with an E. coli pneumonia, take hypercapnia. The investigators weren't very satisfied with that because pneumonia lasts much longer than 6 hours. Donald O'Cronin, in the same laboratory, looked at a more realistic 2-day model of E. coli pneumonia. The data I'll show from this is the histology. We're familiar with lung histology. On the right, you see the control animals, normal lungs. On the left, E. coli at 2 days, established pneumonia. Here you can see below this E. coli for 2 days having been exposed to added CO2. And the slides are not mixed up. The histology is not better. The histology is far worse. How could that be? They hypothesize that if the histology is worse, the pneumonia is worse, it's because there's a greater proliferation of the E. coli. And they were right. They measured the colony counts and found that with hypercapnia, the numbers were not less, they were more. Long term, not so smart. Why was that? Well, they can't be sure. But one thing they thought was if the E. coli are proliferating more, maybe it's because the neutrophils are not working adequately. So they measured neutrophil activity and demonstrated that with hypercapnia, in the long term, it was not increased, it was decreased. So the net effect of hypercapnia in these 2 related models of a clinically related relevant problem, it's kind of like high doses of steroids, barbiturates, general anesthetics, hypothermia, general suppression of energy-consuming processes, which in the short term, if the energy-producing processes are going to harm the patient, ablating them is good, like acute inflammation. But in the longer term, if you need the inflammation to correct infection and to repair, you pay a price. So I have 3 conclusions. Short-term gain, like so many things, is not the same as long-term gain. Adverse effect in this study might actually not be CO2 on neutrophils. That may be an epiphenomenon. Maybe it's because the animals were spontaneously breathing and had ventilation-induced hyperpnea and injury from that reason. We don't know. In an in vivo model, such things are almost impossible to dissect out. The benefits and mechanisms, even from a laboratory in-depth study, are often very difficult to understand and in a clinical trial are usually impossible. Thank you.